This is Brendan Eich. He's the creator of JavaScript, and the original version of JavaScript was done in something like a couple of weeks. It was insane. So before diving into the language, let's talk a little about how we got to be this way. First, just to put some of my own biases on the table, so you know which things are just my opinion and which things are widely accepted. I think JavaScript has a bad reputation that is not entirely deserved. It has some flaws in its design, but I think all languages have some flaws in their design. So using JavaScript tastefully is actually just fine. I think the reason it has such a bad rep and the reason that I tend to bristle about it is because most JavaScript code that is out there is awful, just awful. It's like the work of programmers who don't understand objects or encapsulation or anything. It's cut and pasted from a million different websites, and probably a lot of it, the people who authored it have no idea how it works. You are all seasoned programmers, so you won't have this problem. I also believe that as much as possible, using JavaScript should be a way to enhance the app, but the lack of JavaScript shouldn't kill it. Now, granted, there are certain types of interactions that the only reasonable way to do them at all is by using JavaScript. But, for example, if your web app has a fill-in form, and the fill-in form doesn't have any special elements on it that, other than the usual drop-downs and text fields and stuff, on a page like that, not having JavaScript should not make the page unusable. There's no reason that a page that otherwise would have worked just fine without JavaScript all of a sudden breaks if JavaScript is not present. And one reason for that is, as we're going to see, there's a lot that you can do to ensure that your JavaScript works on a variety of different browsers, different OSs, and stuff like that. But getting to 100% confidence on that can be really challenging. So you have to assume that once in a while, your JavaScript code will fail on someone's browser in a way that you didn't anticipate. And your goal is to minimize the likelihood that that results in your website becoming unusable. Maybe it becomes a little less convenient to use or less whizzy or something. But as much as possible, don't rely on it as a crutch unless you absolutely have to. In terms of an app, if we think primarily about apps that are server-heavy, server-focused, and they are primarily serving a web-based UI to the user, my opinion is that in those apps, something like jQuery is the place to start. So what do I mean by that? First of all, don't do anything that relies on just the native JavaScript bindings without something like jQuery. Because if nothing else, jQuery gives you compatibility across a range of platforms. It gives you some nice higher order behaviors that are not built into the browser's implementation of JavaScript but are super convenient to have. There's been a big movement recently to using essentially full stack frameworks like React or AngularJS for so-called single page apps. We won't talk much about that in particular. I will go as far as to say that as with all tools, you should use the simplest framework or libraries that will serve the needs of your app. So when we started out talking about software as a service server side, we introduced Sinatra as a much, much simpler framework than Rails for building server-side apps. And if you have an app in mind that could have been built with Sinatra, you should build it with Sinatra or something even simpler. Similarly, if you have an app that can mostly be built in HTML5, but with some enhancements that make use of JavaScript in tasteful ways, I think that you need a reason to use a full-blown framework rather than a reason not to use one. They add more complexity, they add testing complexity, they add some maintenance complexity. So if you're going to buy into one, just make sure that it legitimately solves a problem you have, as opposed to it's because I need an excuse to learn the framework. And just as I think TDD is extremely important for actually having self-checking tests for your server, you can do that in JavaScript as well. It is much more painful, but there are tools like Jasmine that help. And a lot of the same techniques that you already know, how to stub the results of calls and return a controlled thing, how to build doubles of objects that have certain canned behaviors so you can control code paths. JavaScript, the language, allows you to do all those things. And Jasmine, the framework, allows you to actually do the testing techniques just as RSpec does for Ruby. So although we won't get to it today, either Tuesday or Thursday of next week, we'll show some examples of how you would rigorously test client-side JavaScript code using Jasmine. As far as I'm concerned, I'm still sort of a skeptic about server-side JavaScript for reasons that I hope will become clear between now and next week. I'm open to being convinced otherwise. Somebody has said, if you looked at Express.js, you would change your mind. I haven't looked at it yet. I'm open to changing my mind. Probably I won't get around to doing that till after the semester's over. So for now, you're going to have to deal with my cantankerous point of view on this. OK, so a little bit of JavaScript history. Where did it come from? It's actually older than most people think. In 1995, Netscape had taken over the world. They were the darling of all startups. They were like the original unicorn. And they wanted to have a simple language that could be used to enhance client-side pages. What they had in mind was stuff like, animating simple things on the page or being able to check input forms before they get submitted to the server. And they came up originally with the name LiveScript, but they decided to change it to JavaScript. Anybody have any idea why? Or want to guess why? You can be cynical. Did you raise a hand, or did you? What do you think? To ride the hype of Java. That is exactly correct. This was around the time that Java was going to save the world because it was write once, run anywhere. At the risk of being snarky, I think it's become write once, run nowhere. But Java was super popular. Everybody thought that Java was going to be the language. It's going to take over the world. For a long time, a lot of classes here were taught in Java. I know some of them still are, but we're recovering from that. But nonetheless, Java was big. So all right, well, let's call it JavaScript. The only thing that JavaScript and Java have in common is those 4 letters. As languages, they're way more different than they are alike. In fact, JavaScript is much more like Ruby than it is like Java. But back to that later. The browser already had the idea of a document object model. This is basically the internal representation of how the document is represented, and it is used by the browser to lay out the document on the screen, to track the user's interactions with different things on the page. So the idea was whatever this embedded language was going to be, that language would have bindings, right? There would be a representation of the DOM that was available in that language. And if you modified that in-memory representation, it would have the side effect of changing what was displayed on the page. And conversely, you could inspect that in-memory representation to learn things about what was being displayed on the page. In 1997, JavaScript was standardized as ECMAScript, which sounds more like a skin disease than a language. But whatever. Officially, JavaScript is a variant of the standard. The standard is this. So, and I can't remember which other variants there were, but Microsoft had one for a while called JScript, which was another variant. But the real important thing happened after that, which is when Microsoft added something to Internet Explorer 5. Yes, Microsoft was the first browser to do this. They added a new Java visible function called XML HTTP request that did this revolutionary thing, which was it allowed a web page that had already been loaded to make an HTTP request to the server that did not necessarily result in redrawing the page. That's all it did. It separated the act of doing an HTTP request from the act of rendering an HTTP response. And in particular, the response would eventually arrive later, and JavaScript would be handed the response and would be allowed to modify the DOM model and change what was on the page in reaction to that. So that's really what made the so-called Web 2.0 apps possible. Google Maps appeared in 2005 and kind of showed people what you could really do with JavaScript if you were clever. And AJAX became a thing, which is asynchronous JavaScript and XML. So called because today there is not any XML to be found anywhere. It's all, now it should be like AJAJ, asynchronous JavaScript and JSON. But we'll get back to that next week too. In 2015, the 6th major revision to the ECMAScript standard was introduced. And it is a major revision. Major. It fundamentally changes some of the programming abstractions in the language. So everything we say from this point on about JavaScript is conditioned on this major, major caveat that JavaScript is continuing to evolve very, very rapidly. ECMAScript v6 adds things like classes, right? JavaScript, most people don't realize, JavaScript doesn't have classes. It has objects, and it has inheritance, but it doesn't have classes in the sense of OOP. And for example, it doesn't make real sense to talk about things like Liskov substitutability in JavaScript. The variable scoping rules have changed. There are some new constructs. Transpilers are becoming more and more popular. So if you've heard of TypeScript, which is basically a language that has strong type checking but can be compiled down to JavaScript. JSX, which is the language that you write your React apps in, also compiles down to JavaScript. Babel is a project that will transpile ES version 6 to older ES versions. Even though ES version 6 was introduced in 2015, a lot of browsers out in the field still don't implement it. So if you're deploying production JavaScript code, you cannot generally assume that the users are all ES6 compatible at this point. But there are transpilers that will generate underlying JavaScript code, JavaScript classic, as I like to call it. And I think the result of all this is pretty soon people won't be writing JavaScript anymore. People will be writing in one of these other higher level languages, transpiling down to JavaScript. And the common denominator is all browsers do have JavaScript interpreters. So, and it's Turing complete, so you can implement any language on top of it. In fact, there's a list of which languages can be compiled to JavaScript. And it's basically every language you've ever heard of or would care about. So I think JavaScript is going to be a target language real soon. And I'm actually not sure what's the best way to cover it in this class. But I will give you at least enough to understand how JavaScript is used in the browser, what the limitations are when it's used in the browser, how the basic mechanisms of things like AJAX work. Because if you understand that, you can understand how to use any of the frameworks that are built on top of it. And we will mostly focus on the use cases that have to do with enhancing apps that are largely server-centric but have HTML user interfaces. We'll talk a little bit about single-page apps that are JavaScript-heavy but still rely on a server piece. We won't really talk about anything as complex as Google Docs, which is all JavaScript at this point, or fully server-side implementations of SaaS apps using things like Node or Express. OK, so usually we get to JavaScript a little earlier in the semester than this. Nonetheless, here we are. And we got a little bit of an intro to it at the end of last week just to sort of get some positioning about it. And once again, oh, there we go. Since we haven't had a computer history minute in a bit, I thought this might actually be an appropriate place for one, because as it turns out, the two languages that we've been using in this class actually have a lot of common ancestry. So the languages Smalltalk, Lisp, or Scheme if you prefer, which is sort of a Lisp dialect, and Self, which is a lot less well known, are intellectual ancestors of both Ruby and JavaScript in important ways. The pure object model that we saw in Ruby, where everything is an object and everything is done by sending messages to objects, that really comes directly from Smalltalk, which was a language that was developed in the early 1970s as a sort of experiment in pure object-orientedness. We've already seen that Ruby has some idioms that come from the functional languages world, like map and collection operations and things like that. As we're going to see, JavaScript actually has a lot of the same thing. And those are great ideas that come from Lisp. Lisp also was one of the first languages to really give us closures, which is the idea that a procedure can see all of the variables that are in scope at the moment the procedure is defined. And then if you call that procedure later, it has access to all those variables. We use that all over the place in Ruby, and even more so in JavaScript. JavaScript's first-class functions and closures come very much directly from Lisp. And finally, Self, which is a language that is less well known, but the inheritance model that classic JavaScript comes with, and the fact that that model is different from what we think of as traditional object-oriented classes, where you sort of stamp out instances of a class, but those instances really all are constrained to have the same behavior. JavaScript objects don't quite work that way, although people sort of try to shoehorn them into that mold. And the inheritance model they do work from, which is called prototype-based, actually comes from Self. And by way of trivia, Smalltalk is the language that was used to develop arguably the world's first graphical user interface. That's a screenshot from, a very bad screenshot, I'm afraid, from the Xerox Alto. Anybody know about what year the Xerox Alto did a demo where they showed windows that were draggable and a mouse and pop-up menus, basically everything you now think of as the basic elements of a graphical user interface? Anybody know roughly what year that was demonstrated, like on a real research prototype that you could actually use? Or want to guess? Shout out a guess. 75. Really close, 73. And the ideas had actually been demonstrated 5 years before that in a demo that I'll probably talk about sometime before the class is over, called the mother of all demos, that happened right here in San Francisco. And Self, like I said, not a language that has a lot of recognition, but it was the language that was the basis of a Newton script. I didn't bring it today, but a couple of days ago at the Computer History Museum, there was an event celebrating the somethingth anniversary of the Newton. The whole design team was there, and I got them all to sign my Newton. I was very excited. So I'll bring that in as a show and tell piece shortly. But you programmed it in this weird little language called Newton script that actually was heavily influenced by Self. So most of the good ideas in languages are not really new. They're recycled, and they just sort of get remixed with good ideas being stolen from different languages every time a new generation of them comes out.